Students, good morning. Welcome to the chemistry class. In this class, we will discuss the second part of the chapter organic compounds containing nitrogen. So, in this portion, we will discuss about the amines. So, what are the amines? So, amines may be regarded as they are the derivative of ammonia in which one or more hydrogen atoms have been replaced by alkyl groups. So, amines are the alkyl derivative of ammonia. For example, NH3 after replacement of one hydrogen and addition of one alkyl group, it will be formed RNH2, that is basically known as the amines. So, the functional group NH2 is known as the amines, that is the primary amines. If we replace two hydrogen and add two alkyl group, then it is known as the secondary amines. And if we will remove all the hydrogens and added all three alkyl groups, then it is known as the tertiary amines. Okay, so these are the basically amines. The functional group for amine is NH2. Okay, now classification. So as I have discussed above, when there is NH2, then it is known as the primary amine. Okay, so these are the examples of basically primary amines. Methenamine, to one carbon. So for one carbon meth, single bond N, or for NH2 group suffix amine is added, so it is known as methenamine. Like that, it is propanamine, and this is known as the isopropylamine, and this is aniline. When at benzene NH2 group will be present, then this compound will known aniline. Okay, or aminobenzene, also known as aminobenzene. Secondary, when there will be two alkyl group and one hydrogen, then they are known as the secondary amines. Okay, the other examples, this and this, in which the alkyl group will be different. In this there are two methyl group, in this there are one methyl, one ethyl group, and in this compound there is one phenyl and one methyl group. So according to the alkyl group, there will be different type of secondary amines. Okay, now tertiary amines. In tertiary amines, there are three alkyl groups will be present. Okay, and they will be same or different. So these are basically known as the tertiary amines. Now quaternary amines means when NH2 group is attached with 4 valency, then it is known as the quaternary. Okay, because nitrogen has only 3 valency, but here nitrogen contains 4 valency. Then in this case, nitrogen contains positive charge, and this negative charge will be present in the form of salt. So this is known as the basically quaternary compounds. The compound having the general formula R4N plus X minus are known as the quaternary ammonium compounds. Okay, now classification depending upon the nature of group. So aliphatic amines means amines in which the nitrogen atom is directly linked to one or more similar or different type of alkyl groups, then they are known as the aliphatic amine. For example, N-propylamine, methyl N-propylamine, or trimethylamine, etc. Now second, known as the aromatic amines, in which the amino group will be attached with the aromatic ring like benzene, then they are known as aromatic. For example, aniline, NH2, benzene ring, diphenylamine and triphenylamine. So these are the examples of basically aromatic amines. Okay, these are the other examples. Now nomenclature of the amines. So how we can write the IPC name of the amines. So as I have tell you before that for NH2 group, suffix amine is used. Okay, and for hydrocarbon chain, the naming will be same as for occurring for hydrocarbons. Okay, so here there is one methyl and NH2 group, so this is known as methylamine or aminomethane. Aminomethane is the common name, but methylamine is the IUPAC name. N-propylamine, because there are 3 carbons, so propyl N-propylamines, yeah, or 1 aminopropane. Okay, isopropylamine or 2 aminopropane. So these are the basically aliphatic compounds nomenclature. Okay, other examples are given here. And for the same the aromatic compounds, then it is known as the aniline or phenylamine. That is known as the N-methyl aniline, that is known as the NN ethylenyl means at the end there are two methyl groups are no attached, so it is known as the N diethylamine. Like that, this N methyl aniline. Okay, it will be the name of aromatic compounds, IPC name. Okay, so there are other examples are given, you can watch here. Okay, so for the suffix NH2 group we will use the suffix NH2 group. Okay, during while writing the IPAC name. Now, isomerism involving in amino group compounds. So first, that is structural isomerism, in which for the formula C3H9N there are three isomers are possible, that is propane 1 amine, N-methylamine and N dimethylamine. So when the compound, the molecular formula are same, for the molecular formula, when the molecular formula is same and their structures are different, then they are known as structural isomers. Okay, now structure of amines. So amines in which there are three atom will be present according to their valency, and there will be one lone pair of electron. Okay, so it is the basic structure of the amine. Now come to the general method of preparation of amines. So from haloalkanes, that is known as the Hauptmann ammonolysis method. In this reaction, alkyl halide RX, in which you can take CH3Cl, react with NH3, then after removal of one H and one X, it will form RNH2. Add another atom RX, then one HX remove and form R2NH, and after adding one more RX, then it will form R3N amine, and after that finally adding one more RX mole RX of compound, then it will form quaternary salt. So it is the basically substitution reaction of the amines and formation of the substitution reaction of ammonia and formation of the amine. Okay, and this process is known as the ammonolysis. Okay, Hauptmann ammonolysis, nucleophilic substitution reaction is, it is a type of nucleophilic substitution reaction. Okay, now what is the mechanism? So you can see amine will attack with alkyl group and halogen will remove, then primary amine salt will be formed. Then this primary amine further react with amine, then primary amine will form. It is the another method for the preparation of amine. Okay, second, by the reduction of nitro compounds, in which NO2 group in presence of these reagent SN by HCl, F by HCl or lithium aluminum hydride, these are reducing agents, means they produce hydrogen to the compound and reduce them and oxidize himself. Okay, so in this nitro compound will reduce into amine. So you can see here this nitro group is converted into NH2 group, because here the reduction process will occur, means oxygen will remove and hydrogen will add. Okay, other examples, CH3NO2, if you take alkyl group, at the place of alkyl group you take CH3, then methylamine will be formed. Okay, next, by reduction of cyanide and isocyanides. So cyanide group on the reduction of lithium aluminum hydride will be converted into NH2 group. Okay, so these are the cyanide group. Other reaction you can see here in the benzene ring. If cyanide group is present in presence of lithium aluminum hydride, this CN group will be converted into CH2 NH2 group. This is basically known as the Mendius reaction. This is named reaction known as the Mendius reaction. Okay. Now, by the reduction of oximes, so RCHONOH is basically known as the aldoxime. The reduction of 4H in presence of sodium in presence of C2H5, then it will convert into RCH2NH2. Okay, so you can see here other reaction, secondary oximes. If you will take the secondary oximes, okay, secondary oxime, then primary amine will form. If you will take normal this ester oxime, then ethylamine or primary amines are formed. So these are the other reaction by which you can prepare, you can reduce the oximes and convert it into primary amines. Okay, and from amides, so RCONH2 reduced with 4H in presence of lithium aluminum hydride, this CO group will convert into CH2 group, means removal of oxygen and addition of hydrogen. Okay, this is known as the reduction. Other example, benzimide, reduce, then CO group will convert into CH2 group. Okay, so this is the process. Next, by reduction of amines of aldehyde and ketones. So then aldehyde will reduce presence of ammonia in primary and amine, and after reduction this amine it will give primary amine. Okay, it will give primary amine. Okay, thank you. These are the basically chemical properties. Okay, next, last one is very important, Gabriel phthalimide reaction. So in this reaction, it is the phthalimide in the presence of KOH minus HOH will remove, K will be add after reaction of RX, the KX will remove and R will be add, and after the dilution of HCl and hydrolysis by HCl process, it will give a phthalic acid and a primary amine. So it is known as the basically Gabriel phthalimide reaction. It is a very important reaction. Okay, thank you. Have a nice day.